morning, guys. First of all, I want to apologize for the printing fail. I feel like I've been giving you guys the slides in every possible different ways every time. But yeah, I did it this time by myself. I'll do it by the department next time. So it's like nicely printed, right? So one thing about the team. So all the teams are formed. We have 13 teams in total. One of the teams I formed it for you. And also one of the teams had only 3 members. I also gave you 2 extra. So then that's for the team. So since your teams are all formed right now, you are ready to start working on the project. Actually, we can do pretty quickly. It's the 18th. All right, on the 18th, you will submit your document and also do your presentation. So you might want to start it now if you haven't. Also, because for phase 1, we have 2 parts, right? The requirement analysis and the conceptual design. This week, we'll finish up all the knowledge you need to know for conceptual design, but now you should be able to work on requirement analysis. Okay? Another thing is the quiz. The quiz last Friday is already graded. So the TA posted the grade, and also I think she sent out the rubric in email. Yeah, so that's for the quizzes. Do you guys want the quizzes returned? Sure. Or if I post it again, so that's more than enough. It's up to you guys. If you want to back it, then we will return it to you maybe on Wednesday. Okay? And that would be a chance for me to like return it and know your name as well. I figure I don't know your name at all. Next thing. Okay. So last time, at the very end of the lecture, we were working on an exercise, right? The factory produces product. And after the lecture, quite a lot of you came to me to ask them questions. We will also discuss that today. Okay? So some parts it's kind of confusing. We'll talk about that. So let's start from a couple of slides that we missed from last lecture. Remember, I didn't finish all of them, right? So let's start from this one. So this is an instance of managers. Okay? So if we start by looking at the managers relationship, who can tell me, judging by here in the department, what to what is the managers relationship? Remember, we have 4 kind of combinations. This can be one to many, right? Because for here, one employee can manage multiple departments. However, one department can only be managed by one employee. Okay? Then let's take a look at here. Since not all of the employees right here are involved in the manager's relationship, what kind of participation we say it is? Partial. We didn't get into too much about the participation last lecture, but we will talk about it more this time. Okay? As for the departments, you can see all of the departments are involved in the manager's relationship. So what kind of participation we say it is? Yeah, it's total participation. Okay. So today we'll talk about more on the participation. All right. Last time we paid quite a lot of attention on the key constraint. Right. Remember, we're saying if we have the arrows, then it will represent the at most one constraint. Okay. So let's take a look at this. Okay. We can also add arrows when the relationships are ternary. Remember what ternary is? When we have 3 entities involved in one relationship. Okay, we say it's a ternary relationship. So let's say today we also want to add a key constraint for this ternary relationship. Right here, we say each employee can work in at most one department. How would you modify this diagram so that it satisfies that? Arrow on which one? Employees to here, right? Everyone agree? Yeah. So then that will give you the result that each employee can work in at most one department. Okay? Who's sort of unclear on this? Okay. So let's take a look at the instance for that. Okay, so here, if we look at employees to the department, it looks kind of bizarre right now, but if we look at the employees to the department, you can see one employee will only link to one department, right? And also from here, we will link to the location, that is where the employees work, all right? But how about if we look at the departments to the location? Can we find any that's like one department locates in multiple locations? If you trace it from the department. We can find different departments in the same location. Let me see. What, 6? 56? Ah, yeah. So 56, for this employee, it works in Delhi, but for that employee, it works in Rome. Okay? How about employee to the location? Can
one location have several departments?
say it again?
So one location contains several departments?
Yeah, so for the employee to the location, that will be many to one, right? We can see this employee works in Delhi, while this employee as well. Okay, so this is how you can interpret from the instance. If we give you an instance like this and tell you, oh, compare which entity to which entity, is it many to one, many to many, you should be able to answer that. Okay, so let's take a look on the quiz from last time. Remember last time, one of the requirements I asked you to change it from by only one factory to by at most one factory. And at that time, you guys were kind of like, why would you change that? That's actually because recall that when we have the arrows indicating the key constraints, it's for at most, okay? It's for the upper bound. So when I say at most, do you think it's okay for a product in this scenario to not produce by any factory? Yes, that will still satisfy the diagram, right? So what if we want to make sure a product has to be produced by at least one factory? We'll talk about it later, okay? Another thing that was raised, another question that was raised for this quiz, I think maybe applies to other, like, employees work in departments. What's your name? That you raised the question about the relationship having two primary keys. Yeah. Huh? It's kind of hard. Okay, anyway, she raised the question about, remember I said for a relationship, you identify that by the two entities that are involved in the relationship instead of having an ID for the relationship, right? So the question was raised that when we store the information in the table, isn't that weird if we identify that by two primary keys, right? Then what is the primary key for this one? It should have only one, right? I was gonna talk about it today, but I realized it shows up in chapter 3, so we'll wait and see, okay? Just keep that in mind for now. Keep that in mind, even though we say we are gonna identify the relationship by two involved entities, but we won't identify them saying that it has two primary keys, okay? Also, if you look it up, sometimes the design will give them unique key to identify that, but I think in different kind of practice, they have different rules, and for our textbook, they would just say, oh, we don't have special extra key for the relationship, okay? Another thing about the quiz is that quite a lot of you came to me and say, is it okay that we have a factory locate city?
instead of just saying factory with city attribute, right? So that's the only change compared to the last one. What do you guys think? Is this valid?
City doesn't have any attributes, so
Yeah, so if you do that, unless you create like a city with maybe a like ID for that city or a name for that, then that would make sense, right? Also, another thing is, if you don't have anything else to store about the city, is doing this necessary? Not, right? Even though if we add some attributes, then it's valid, right? It's not wrong, nothing wrong about it. But it won't make sense because it's just a city information and you factory locate city. If you say, how about product? We can say product has a color, right? Then you can expand the attributes. All of them can change into entities, right? So it's not necessary, but if, like Bertie said, if there's like an attribute there, then it's actually valid. Okay, it's just not necessary. So that's for the quiz last time, okay? Let's move on and talk about the participation that I talked about earlier. We have total participation and partial participation. All right? So today we'll talk about the participation constraints. So participation constraint defines the participation types of the entities. What are the two types of participation? Total and partial. Okay? So one of the examples is the one that we just said earlier, the participation of departments and managers in total participation, which means that for the manager relationship, all of the departments has to participate. So for the manager's relationship, department is total participation. Okay? So if the participation of an entity set in a relationship set is total, then the way we denote that in the ER diagram, we connect them by a thick line. Okay? So you don't want to get confused between participation constraints and key constraints. Okay? For key constraints, we denote that by an arrow, but for participation constraint, we use a thick line. Okay, so let's try out an example right here. Okay, right here I haven't denoted any constraints on it, and you will be the one to add it on. Okay, let's think about 3 requirements one by one. So let's say for the first one, each employee has to work for at least one department. So if it's at least one, it's the lower bound, not the upper bound, right? So what should you do for this first requirement? Thick line between, yeah, employees and work. Yeah. That'll be there. All right. I don't know whether that is that obvious that it's a bit thicker. Okay. I was like adjusting the thickness of the line. Okay. How about the next one? If we say each department has to have at least one employee. This one, right? We make it a thick line. Okay? How about the third one? We say each department has to be managed by exact one employee. How can we break down the idea of exact one?
So at least one and most one.
Yeah, it's at least and at most one. So what would you do with that then? Yeah. So from the department to the managers, not only you add a thick line, you also make it an arrow. Okay. Any question right here? Okay, so let's say we want to add more requirements for the quiz from last time. Okay, so this is the exercise from last time. If we say we want to add this constraint, each product can only be made by exact one factory. How will we change it? Because if we follow this diagram, it is each product can be produced by at most one factory, right?
It will become thick that one.
Mhm. The thick one on the right. Okay. Okay, so that's for the participation constraint. Okay? So don't confuse that between the key constraint. All right? Then the next concept, before I move on to the next slide, I want to talk about, let's imagine a scenario. So sometimes in the database, the data you will want to manage will have some entities that rely on certain entities in order to exist. For example, in a university, for the faculties, they can have their families also be in the insurance plan, right? So if the faculty leaves the university, do you think that insurance will still apply for the family? No, right? So for this kind of entities, for example, the family, we call them the dependents, we call them the weak entities, all right? So entities that do not have key attributes are called weak entities. By not having key attributes, I mean, for example, let me see. Imagine I'm a faculty, even though I'm still not. And imagine I have family, even though I still don't have. Okay, say I have a kid. And when I store the information of the kid in the university database, do you think the kid has to have a key attribute, like a primary key? Or when we identify the kid, it can just go through me, right? So for weak entities, they don't have key attributes, all right? So the example will be the dependence of a department's employee. So how do we identify weak entity? A weak entity can be identified uniquely only by considering some of its own attributes. For example, I can have more than one kid, right? So when we want to identify the kid, like which kid, then it would depend on the attributes of the kid. For example, I have a kid called, this is so awkward, I have a kid called Ben and another called Amy, then we can just identify that by their name, plus the primary key of mine. Okay, does that make sense? So then, by doing that, you don't actually have to have the primary key for it. Oh, the first one, right?
No, I'm saying that when you say that you don't have key attributes, what?
Oh, by that I mean they don't have like the keys to, for example, primary keys. So, for example, you don't have to have the dependent to have IDs, things like that. So, the entity that has weak entity associated with it, we call it the identifying owner. Okay, so just like the example I made up earlier, I will be the identifying owner for the two kids.
The example that you have taken kind of as, like, in terms of kids, there will always be less. But if we take some other example where we can have a lot of, like, a lot of entities in the weak entities, so in that case, we have to take a lot of attributes to identify them uniquely. So why shouldn't we like just have a primary key for the weak entities too?
One of the reasons is because it's easier to manage when you remove the identifying owner from the database, then they all are gone as well. Yeah, so you don't have to have extra things storing there. That's a good question. Okay, so let's see how we will denote weak entities in the ER diagram, all right? So say we have employees having the policy for the dependents, okay? Right here, let me see. Okay, right here, I now put this because one dependent in the system can have only at most, relate to at most one employee, okay? Let me see. Okay, so for the dependent, that would be the weak entity in this example, right? Weak entity is dependent. And the employee will be the identifying owner, right? So, to denote that the entity is weak entity, the way we do it is we draw the thick line around the entity box. Okay? So if you draw a thick line around the dependence, you're saying that's a weak entity. Okay? And also to denote that the relationship is associating with the weak entity, you also draw a thick line around the policy. So another thing is that if you look at here, this is the thin line, okay? So if you say a dependent will have at most one employee in the system that is associated with the policy. Do you think this makes sense? Because if we allow that, this is a thin line, right? You can say I have a weak entity in the system not relating to any employee. So how can we change that to make it valid? Make it make sense. Yeah, you change this to the thick line, so then you are saying the constraint, every dependent have to have exact one employees in there, okay? So that's actually the constraint for weak entities. So, let's see. Earlier I said, okay, if I have kid, then not only can the kid be identified through my primary key, but also they have their own attributes. Yeah?
Why are you putting thick line around policy?
Oh, it's just saying that that's relating to a weak entity. So this relationship is associated. Yeah. So, as I said earlier, not only to identify my kid, not only does it have to go through my primary key, but also have to go through some of the attributes of my kids. So if I have multiple kids, then I know which one they're talking about, right? So to do that, which attribute do you think will be a good choice? Name, right? So to denote that this is the attribute you want to use for identifying which dependent it is, you draw like a, what's it called? Dotted line or dashed line. Yeah, under that. So for primary key, for the identifying owner, it would be just solid underline, right? And that one, you put the dash line. So we call the key name the partial key. Okay? So if we take a look at this one, do you think there are any constraints of how many dependents an employee can have? If we go from here to there, no constraint, right? One employee can have as many as he has, but not the other way around, right? Dependents can have exact one employee associated with the policy. So we say the owner entity set and the weak entity set must participate in a one-to-many relationship. Make sense? Right? One-to-many. From the employee to the dependent, that's a one-to-many. Okay? So earlier in the previous diagram, we have the policy relationship. So all of those, let me see, all of the relationships that are like policy, we can call them the identifying relationship set. Okay, just another name for saying that. So, what kind of participation will the weak entity set have in the identifying relationship set? When we look at the dependent, what kind of participation does it have? Total, right? Because we don't have any dependents left out in the database. Okay. idea for weak entities. Okay? Let's look at another one. It's called class hierarchies. When we denote that, we use ISA, it just is up. Okay? So I guess most of you have learned object-oriented programming, right? So object-oriented programming, I put objective, I'm sorry. It's object. Okay, so when you learn that, you can inherit some objects, some classes, right? So why do we do that? I don't know whether one of the classic examples you guys learned is like vehicle. You have one vehicle and then the ones inherited can be a car or like a boat or whatever, right? So that's a classic example for inheritance. So right here, we also have that in the ER diagram, okay? So if we say A is a B, then that means every A entity is also a B entity, okay? So for example, here we can say A is the car, B will be vehicle, right? Or here we can say, this kind of weird example, maybe we can say student is also people in university, right? Faculty also people, okay? So it means whatever attributes B has, A will also have it, correct? Okay, so here we have an example based on our favorite department employee example. So say we want to have an hourly employee, okay? Then hourly employee is also an employee, right? Therefore, the attributes for hourly employees are attributes for the employee plus the hourly employee, right? So how can we denote that in our ER diagram? So here we have these kind of different entities, all right? So say we have an employee's entity, that's like the vehicle we just talked about, or maybe this is different kind of cars, or car and boat. So employee have these different kind of subclasses, and hourly employees is an employee, and a contract employee, also an employee. To denote that, you draw a little triangle, okay? So you read it from bottom to top, okay? Hourly employee is a employee. Contract employee is a employee. Ready? Okay, so there are two different ways that we can view this concept. We can either go from top to bottom or from bottom up. Okay, so if we look from top to bottom, okay, it's saying like we identify subsets of an entity set that share common distinguishing characteristics. So that would be for specialization, right? We go from employee to hourly employee or contract employee. Okay. So for identifying subsets of an entity set, we call them the superclass. Okay, I guess like all of you must have the knowledge for that. So that's for specialization. Then I guess it's pretty easy to figure it out. If we go bottom up, what would we call it?
Generalization.
Yeah, and that would be generalization. Okay. So for generalization, it's to identify some common characteristics of a collection of entity sets. Okay. Also create a new entity set that contains entities possessing these common characteristics. So it is possible at the beginning of your design, you just have hourly employee and contract employee separate. And then when you identify them, you figure out, oh, maybe we can put them together, then that's when you create the employee and then have them as hierarchy. Okay, so that's just a process. So whenever you want to apply the is concept, there are different constraints that you want to think about. Two constraints, okay? For example, the first one, we want to determine whether two subclasses are allowed to contain the same entity. What do I mean? For example, in the hourly employee and contract employee example, should we allow an employee to be hourly employee and a contract employee at the same time? Then intuitively it should be no, right? It's kind of weird. But in other scenarios, it's possible that, it can be both. So this we will call the overlap constraint, okay? Whether the subclasses have any overlap between them. Another constraint you will want to think about is that we want to determine whether the entities in the subclasses collectively include all entities in the superclass. For example, again, our employee example, does all of the employees in the hourly employee plus all the employees in contract employee together make all of the employees in the employee entity? That, does just taking two of those cover all of the employees? So that would be the covering constraint, okay? So these things, there's no exact yes or no when you design it. It just depends on how you want to design it, okay? And it's highly application dependent, okay? Let's move on. So there are, I'll just kind of talk through this. There are different reasons why we want to use the concept of ISAP. I found out it's not a very popular concept to be adopted when students design their project. Maybe they think, they don't see the benefits or kind of risky to use it, you're afraid of using it wrong. But there are still reasons for using that, okay? For example, you want to add descriptive attributes specific to a subclass. So there are attributes that apply for the hourly employee, but not apply for the contract employee, okay? Or another reason would be you want to identify entities that participate in the relationship. Let me see what it means. I forgot what I was writing. So motor vehicles include motor boats and cars. Both need to be licensed, and the license to relationship between motor vehicles and owners. Oh, okay. So for example, we will have like a motor vehicles as the superclass, right? And it is a motor boats or cars. And if we say we want to have a license relationship, then the license relationship can just directly connect to the motor vehicles, the superclass, instead of connecting to both. Okay, so that would be another reason for using that. Before we move on to the next concept that I want to talk about, that's the last one for ER diagram, I prepared a little question for you. So just like last time, read through these requirements and try to draw the diagram, okay? So these will not only based on the basics we learned in last lecture, but also a little bit up until here in this lecture, okay? I made it up myself, so if you find anything wrong, just, tell me. If you, later when I reveal what it is, what the diagram is like, and you think it's wrong, feel free to tell me. I'll give you 5 minutes. Oh yeah, don't draw the attributes, just draw the entities and relationships. Okay. Who wants a little bit more time? Okay. 30 seconds. All right. But before I show you how it's supposed to look like, can you tell me what components you use in your diagram?
People, there are actors and characters.
We have people as the entity. Okay, tell me the entities.
People,
movies, actors, directors, characters.
Okay. So what are the concepts you use for maybe grouping the entities together?
It's
Is for
people,
people.
actors, directors.
Yeah. Okay. So are there any weak entities there?
Characters.
Exactly. That sounds awesome. Okay. So that's how it's supposed to look like. Okay. And we also have a couple of constraints, right? So as I said before, let me take the requirement. The first one, I say people in the movie industry can be actors or directors. So then we have people as the superclass, can be actor, director. Okay? The second one, people works in movies. So we have people that works in movies. Okay? If you spot any mistakes, tell me. The third one, each movie has to have at least one people working in it. So that's why we have the constraint right here. You guys have that? Okay, but not the other way around, right? Because it's fine if at some timestamp some people in the industry is not working in any movie. Right? Okay. Fourth one, maybe the trickier one, I guess. Movies have characters. Okay, so movie has characters, and each character can only belong to exact one movie. So that's why we have the thick arrow, right? Also, if the movie ends up not released, the character will not exist. So that's why we change it to a weak entity, okay? If the movie disappears, then the character won't exist either. So that's for requirement 4, okay? So for the last requirement, we say each character has to be played by exact one actor. So actor as a character, okay? And we want the character to be played by exact one actor. So here's the tricky part because, let me see. Do you guys think this should also be with thick lines? Yeah, I'm confusing myself. If, yeah, no, because, okay, if something happened to the actor disappeared, but this still stays, okay. Ready to move on? Or you want to copy a bit more time? Okay, let's go to the very last concept that we'll learn for the ER diagram. That's called aggregation. Whoa, whoa. I don't know what's going on. Ignore that. Okay, so the last concept we want to talk about is called the aggregation, okay? That's another fail today. Okay, sometimes we have to model a relationship between collection of entities and relationships. Okay, so far it sounds confusing. Aggregation allows us to treat a relationship set as an entity set. Okay, I'll show you how it looks like later. So if we want to denote aggregation, we use the dash box around the relationship set to denote aggregation. Okay, I'll show you how it looks like. Sounds still vague. Okay, so you use dash box. So this is one of the examples when you want to use aggregation, right? So for example, we have this project department relationship. That's for a sponsor. So you can say a department sponsor a project, okay? And you want to have someone monitor the whole relationship. So we have employees that want to monitor the whole relationship. So this relationship neither go here nor there, right? So you want to go to the whole set of the sponsor relationship. To do that, we just add a dash box, okay? So then, what the employee is monitoring is the whole sponsor relationship set, okay? I think this one is used a lot rarely, so if you can think of it in your project, that would be great, but I don't think it's that frequently used. Okay, so that's it for the ear diagram. Up until here, we have learned all of the components you would need to know, okay, for the ear diagram. And after here, we will do some comparison because so far you have learned kind of, everything in every component, and you might be confused when you want to use what. So in the last few slides of today and next lecture, we will make some comparison of the usages, okay? So before we do that, let's wrap up real quick. So for conceptual design with ER model, you guys have practiced a few of the exercises that I made up. So there are different steps that you might already know because when you were thinking, you exactly think this way, right? So when you look at a question, you would think, should a concept be modeled as an entity or attribute? For example, earlier when you read through the requirements, actors, you would, naturally, intuitively make them the entities, right? And also you would think, should a concept be modeled as an entity or a relationship? Okay? Then later on, you might think more complicatedly, what are the relationship sets and their participating entity sets? For example, sometimes in the examples we have relationships that actually involve more than two entities, then that turn into a ternary relationships, right? Okay? In the end, you will think about whether we should use aggregation, which is quite rare, but sometimes the scenarios might still occur, okay? Before we end today, we'll just do one comparison, okay? That's the entity versus attributes, okay? So let's think about, when we store the address information for employees, do you think it should just be an attribute or an entity? Entity, right? So it depends on how we want to use the address information and the semantics of the data. For example, multi-value. If we have several addresses per employee, then we must use entity, okay? Not attribute, right? So if the structure is important, we must model it as entity as well, right? Like we said, I think quite early, last week, one of the lectures last week, we say you can have, when you want to turn an attribute into a structured attribute, for example, name, it has first name, middle name, last name, you can turn a whole name into an entity, right? So that would be the usage between entity and attribute. So let's take a look at, we want to have several addresses per employee, this kind of idea. We want to have several something for an entity, okay? So let's look at the top one first. They're separate, okay? So for the top one, for an employee to work in a given department over more than one period. So a bit different from before, this works in relationship we have, instead of having just a since, we have from and to, right? So that can give you the ability to compute the duration. What if it's possible for an employee, let's say a faculty, go on sabbatical and come back later? Then there has another set of from and to, right? So how should we fix that? Because if you only have this, then you can store only one from and one to for a one working relationship, right? So how can we change that so we can store multiple pairs of from and to? Make an entity where? You put it works in with an entity, and then you put the from into, okay? Exactly. So you can just add, let's say, a duration, right? And then you put a from into. Well, why does it have two? Yeah, ignore that. I'll figure that out next time. I don't know why I had two on the line. Don't put the underlines this time, just yet. Okay, so you add identity of duration from a team. Okay, so that's it for today. Don't forget the homework one is posted, right? And it's due next Friday in class. I think you should be more than ready to work on it now. Okay? Everything you learned so far is sufficient. See you on Wednesday.